Well, thank you for your welcome. When we've got the computers all sorted out, that wasn't my computer that did that. So what we're doing today is we're looking at just a select part of the God Delusion, because it's a fairly large book, and I'm looking mainly at chapter 4, and I'm looking at a scientific response to what Professor Dawkins says in chapter 4. If you're interested in more the theological side of things, there's a number of books out. One I've got here is the Dawkins Delusion by Alistair McGrath, who actually is I believe he's a professor in the same university as Professor Dawkins, who's written a more theological response to some of Dawkins' arguments. So if you're interested in that, we have a bookstall here actually for books, if you want to buy some books that discuss the creation-evolution debate. They're all written from a Christian point of view, defending creation as opposed to evolution, which is my position. But this evening's topic is looking at the scientific evidence that Professor Dawkins puts forward to suggest that there is probably not a God, and why I, after reading that, still maintain my position that there is a God. But we'll get to that later. I want to start off with a quote. And the next time somebody tells you that something is true, why not say to them, what kind of evidence is there for that? And if they can't give you a good answer, I hope you'll think very carefully before you believe a word they say. Anybody want to hazard a guess at who said that? Richard Dawkins said that. He wrote that in an open letter to his daughter to encourage her to question the things people say. And I think that's a very good thing. We ought to do that. We ought to listen to Professor Dawkins, and we ought to say, okay, what is the evidence? And let's look at the evidence. And that's what we're going to do tonight. We're going to look at the evidence, and we're going to see whether it actually supports Professor Dawkins' thesis, or whether, after looking at the evidence, we can still have reason to believe that there might be a creator God. So I'm going to look at four main areas. We're going to look at natural selection, because Professor Dawkins claims that natural selection explains why we're here. We're going to look at something he calls the worship of the gaps. He claims that creationists worship the gaps and put God in the gaps. There's actually a misunderstanding of our position. We're going to look at the origin of life and the variety of life, because this is a very important issue when we're thinking about origins, when we're thinking about creation, evolution. Where did we come from? What is the origin of life? And how can does natural selection explain that variety of life? And we're going to finish off by looking at science and faith, because Professor Dawkins has some very interesting things to say about what faith does to science. And we're going to look at the evidence there too. So let's look at natural selection with some more quotes from Professor Dawkins' book, The God Delusion. He claims that Darwinian natural selection is the only known solution to the riddle of where the information comes from, the information contained in living systems. We all have a genetic code, and that genetic code contains information. Where's the information come from? Well, Dawkins says that Darwinian natural selection is the only known solution to that riddle. He also says that slowly increasing complexity explains the illusion of design. Biologists often talk about design. They do it all the time. And they often get misunderstood, because some people think that if they're talking about design, there must be a designer. Well, when I talk about design, I do mean there must be a designer. But Professor Dawkins suggests to us that slowly increasing complexity actually explains this illusion of design. And he claims, in fact, that natural selection is a better alternative than the God alternative. So let's look at natural selection. Let's just look at a couple of examples of natural selection, and let's see what natural selection can do for us. Well, of course, we've all probably heard about Darwin's finches. On the islands of the Galapagos, off the coast of South America and the Pacific, there are 14 species, or give or take. Maybe there are 12, maybe there are 15. It's a bit unclear. But there are about 14 species of finch. And here are the pictures of some of them. And they differ mainly in beak size and shape. So the distinguishing features of these different species are the beaks. You look at the beak and you can identify different species. And this is mainly associated with the different types of food that they eat. There are other differences as well, but we're going to just look at the beak and the diet that these finches use to survive, and what that teaches us about natural selection. Here we have one of the finches with a very large beak, Geospitzer magnirostris. There's no why I didn't do Latin. And then we have G. scandens, And you can see the beak sizes are different. You've got on the left-hand side a bird with a very deep beak, and on the right-hand side a bird with a narrow beak. And this is associated to the type of food they eat. And the bigger, stronger beak you have, the larger, harder seeds you can eat. And there's quite a lot of research that has been done on these finches by a couple, the Grant couple, Mr. and Mrs. Grant, who've lived on the island, have worked for 20 years or more studying these finches. And there's lots of different evidence that shows how the size of the beak determines the size of the seeds there. Here's a graph. You've got 3 finches here, smallest beak on the left and the largest beak on the right. And the larger the beak, the larger the seeds. So the bird on the right-hand side there eats seeds that are about 5 to 7 millimeters in diameter, and they can crunch those up and survive quite happily on them. But what happens in terms of natural selection is that as things change on the island, the size of the beaks change. And here we have some very interesting work which is affected. We find that the beak is actually affected by the weather. Well, not directly by the weather, because the weather affects the amount of seeds that are available, the type of seed that's available. So in dry weather, you tend to have less seeds, which are harder, more shriveled up, more difficult to eat. So the birds tend to have larger beaks, because the larger your beak, the more force you can apply, and the more easily you can obtain food. Whereas if you've got a small beak, you tend to do very badly in these kind of conditions because the food is too difficult to eat. So you tend to die out. So what you find is, as you measure the beak depth over the years, starting from 1979 up until 1982, there are some blips. Every time there's a very dry year, the seeds type that's available is very hard and dry. So the beak size of the finches, you find, has increased because the ones with the small beaks can't eat, so they die. So here we have natural selection in operation. Basically, the food is the environment that changes as a response to the weather, and the weather can have a big effect on the type of bird you find. Well, big effect. Actually, we're only talking about a few millimeters in beak size, but it is a difference. And then when there's wet weather, more seeds are available, which are much easier to eat, and you get the birds with the smaller beaks coming back. So you can measure the beak size, and this is exactly what happened in 1984. Wetter weather, the beak size decreased because there's much more available food, and the type of seeds that are available were much easier for the birds with small beaks to eat. So here we have natural selection. We have the survival of the fittest. Those birds which are best adapted to survive in the harsh conditions survive. Those which are not able to obtain food, they of course die and don't leave many offspring. So you have a variation in beak size responding to that environmental condition, and that's observable biological effect. That's natural selection, and I have no problem with natural selection. Natural selection is an observable thing. You can measure it, you can quantify its effects, just as has been done here, and this is nothing to challenge anybody's faith. I'm perfectly happy with the idea of natural selection, and it's not going to cause me any problems. So there are many things where I can agree with Dawkins, and I agree that natural selection is a very important phenomenon in biology, and it's very important in understanding biology and how biology operates. Let's just look briefly, though, at genetic variations and how that fits in with the story. Again, picking one of the very well-known examples of evolution, the peppered moth and a phenomenon called industrial melanism. You may well know the story. The peppered moth is a moth which is got a basically mottled pattern, and you have here in this picture actually 2 moths, one of which is rather more easy to see than the other. There are 2 varieties of peppered moth. One is the dark form, one is the lighter form, and in case you're having trouble, the lighter form one is here in the green circle. You can probably see it now. And what happens is, the story goes, with pollution during the Industrial Revolution, the pollution killed the lichen on the trees, turned the tree trunks black, and so these light-coloured moths were much easier to see, and the dark moths replaced the light form. Here we have evolution in action. Here we have actually a change in gene frequency, because the gene for the dark form became more common than the gene for the light form, except it probably isn't just one gene, it's probably a bit more complicated than that. But it's an example of evolution in action, or at least it's believed to be an example of evolution in action. And here we have pictures which show you the 2 different forms on 2 different backgrounds. On the left-hand side you have the normal tree with a lichen, which is light-coloured, and